Hello everyone, today we're going to work on section 5.2, verifying trig identities. We worked on these a little bit before the winter break, and today we're going to continue working on trying to verify trig identities. We have 5 guidelines here to try to help you get going. Number 1, start with the most complicated side of the equation. And number 2, factor, add fractions, square binomials, create a single denominator if possible. Number 3, use your fundamental identities, your Pythagorean identities whenever possible, your hints on your green sheet. Number 4, convert all terms to sines and cosines. That's really important. That really goes a long way as far as getting you started. But most importantly, try something to get you going. Don't just look at it and say, I don't know what to do. Figure something out to get you started. So looking at number 1, we want to try to verify that the left-hand side equals the right-hand side. So I want to start with what looks like would be the most complicated side, and obviously the left-hand side looks more complicated than the right. So looking at the left, I see that secant squared minus 1 in the numerator, if you look on your green sheet, secant squared minus 1, this right here is, sorry, let me try that again. Okay, this right here is tangent squared on your green sheet. So this is tangent squared. Now, I really should put my little theta symbol there as I'm working this out. You'll notice that as I continue to work through this, I'll kind of drop that off through my process, and then I'll kind of stick it back there at the end. You can continue to write the theta symbol, but I just kind of leave it off just for saving, shortcut there. Alright, so I'm going to write that tangent squared replaces the numerator, and then I have secant squared in the denominator, and I want to still try to simplify this and see if I can figure out a way to make this equal sine squared. Now, we also know that tangent squared, because one of the rules that we just looked at said convert to sines and cosines. So I know that tangent squared is sine squared over cosine squared. So that may be helpful. We'll have to see. This fraction bar right here means to divide. So I'm going to put a division symbol because this means to divide. And secant squared in terms of sines and cosines, secant squared would be 1 over cosine squared. So I've turned everything into terms of sines and cosines. Now, in order to divide fractions, I multiply by the reciprocal. So I'm going to have sine squared over cosine squared times the reciprocal, which means I got to flip it. Now my division is a multiplication. Now that I have multiplication, I can cross reduce there, mark out the cosine squareds, and I'm left with sine squared of my angle here, which happens to be theta. It's just instead of writing my little theta symbols all through my work, I just kind of stick it there at the end. And all of this was work that we did on the left-hand side of the problem. Okay, and this right here was the right-hand side of the problem. We didn't do anything to that. So what my final step should look like is proving that the left-hand side of the equation equals the right-hand side of the equation. And that is your final answer. Just make sure that all of your work for the left led up to this, and then if you do any work on the right, which we didn't here, that all your work on the right leads up to that. Okay, let's try number 2. Obviously the left-hand side is more complicated than the right-hand side with number 1. So looking at the numerator, sine squared plus cosine squared on your green sheet is number 1, or is 1. So 1 over cosine squared. There's no addition or subtraction here, so that means times secant squared. Now, you need to start recognizing when you are looking at reciprocals. Cosine and secant are reciprocals. of each other, and reciprocals, when they are multiplied together, equal 1. Cosine and secant multiplied together equal 1. Now they're both squared, so cosine squared times secant squared is 1. So this is 1 over 1, and 1 over 1 reduces to 1. So the left-hand side of the equation is 1, and the right-hand side of the equation is 1. And that's what number 2 looks like. Right, number 3 is going to involve finding a common denominator. And before we do that, I want to show you something with finding a common denominator of just plain old fractions. Okay, I'm going to write 3/5 plus 1/2, and let's look at finding a common denominator the old way, and then I'm going to show you a little shortcut which I'm going to use when we do the trig functions here. Okay, so if I want to add these two fractions together, the common denominator would be 10. So you would multiply this side by 5 and this side by 5, and you'd come over here and you'd multiply this side by 2 and this side by 2. So this would be 6/10 plus 5/10, which would be 11/10. Okay, and that's how most of you would do common denominator there. There's nothing wrong with that at all. But I want you to follow along closely here, because what I'm getting ready to show you here for a common denominator, I'm going to do from here on out with finding a common denominator for these trig functions. It's the same process, just a little bit different. Okay, so your common denominator would be 10, and you'd get the 10 from multiplying 5 and 2 together. So I'm going to write that as 10. 5 times 2 is 10. Plus, so I'm going to put a plus. But watch what happens to the numerator. I'm going to multiply 2 times 3, and I'm going to get 6. And then 5 times 1, and I'm going to get 5. And then there's your fraction. 6 plus 5 is 11 over 10. Okay, it's not a proportion, it's not cross multiplying, it's just a little bit shorter way or a little bit different way of getting a common denominator. Okay, so keep this in mind for common denominator. Oops, too many humps there. Common denominator. Okay, so let's try number 3. I need a common denominator to add this fraction plus this fraction. Okay, my common denominator has got to involve one minus sign and one plus sign. So my common denominator is going to be whatever 1 minus sign times 1 plus sign would be. Now, if I take 1 minus sign and 1 plus sign and I multiply them together, I'm going to get 1 minus sign squared. So that's what my denominator is going to be, 1 minus sign squared when I get a common denominator. Okay, it's like taking your 5 times your 2 and getting your 10. So that's your common denominator. Now, for your numerators, you're going to take 1 plus sign and you're going to multiply it times 1, which goes in the upper left hand corner. So 1 plus sign. And then you're going to take 1 minus sign and you're going to multiply it times 1 to go in the upper right hand corner. So 1 minus sign. And what you've just done is you have added two fractions together and gotten a common denominator. And we're going to try to see if we can make this equal 2 secant squared. And we're getting ready to work on that. Alright, so in the numerator I have 1 and 1, which turns out to be 2. My positive sign and my negative sign, those cancel out. Now look on your green sheet. 1 minus sign squared is cosine squared. Okay, now look at where you're trying to get. You're trying to get to 2 secant squared. So you have the 2, and the cosine squared's in the denominator. So think about what 1 over cosine squared would be. Wouldn't that be secant squared? Okay, but you have a 2 in the numerator, so you would have 2 secant squared. So that's where the 2 secant squared comes from. And instead of the theta symbol this time, we have a u. So 2 secant squared of angle u on the left-hand side simplified equals 2 secant squared u on the right-hand side. And there is number 3. So let's try number 4. No common denominators necessary here. But on number 4, tangent squared plus 1, again looking on your green sheet, that is secant squared, times cosine squared x minus 1. Now if you look on your green sheet, you don't see this exactly. What you'll see is you'll see 1 minus cosine squared of x, and you'll see that that is sine squared. But if I flip it around, how about cosine squared of x minus 1? So since these are flipped with different signs, then that means your sine squared is going to have a different sign with it, since these are flipped and the signs are changed. So this is going to be negative sine squared. Okay, turn things into terms of sines and cosines. So secant squared is 1 over cosine squared times negative sine squared. And always look at where you're headed. You're trying to end up at negative tangent squared. So if you multiply these together, that's negative sine squared over cosine squared. And isn't sine squared over cosine squared tangent squared? Yes. And you have a negative. So you are at negative tangent squared of angle x. That's the left-hand side. Negative tangent squared of angle x on the left equals negative tangent squared of angle x on the right. Okay, example 5. This one, if you're having a hard time looking at it and deciding which side is going to be more complicated, I'll tell you that it's more complicated to add than it is to multiply, because when you have to add, sometimes you have to get a common denominator. So on number 5, what I'm going to suggest that you do here is we're going to convert the left-hand side to sines and cosines, and then we'll see what happens there. Okay, so tangent is sine over cosine, and cotangent is cosine over sine. Now if I want to add these together, I need a common denominator. So let's do a little common denominator trick. My common denominator is going to be these two things multiplied together, which will be cosine times sine. This is a plus, I'm going to put a plus. So multiply up and to the left for right here. So that is sine squared. Up and to the right for the right hand side. So that's cosine squared. Okay, sine squared plus cosine squared is 1. So I have 1 over cosine times sine. Now always look at where you're headed. You're trying to get to secant and cosecant. Well, 1 over cosine is, that is secant, and 1 over sine is cosecant. So we are already there. So secant of x and cosecant of x, that was the left-hand side. I'm going to kind of break that off. So that equals the, that should be an S. Okay, so secant of x and cosecant of x, this was my left-hand side simplified, equals secant of x, cosecant of x, which was the right-hand side, which I did not have to simplify. Okay, a couple more examples here. This one is different than all the ones we've done so far. On number 6, this side is more complicated. And so we're going to start over here. Start here. If I told you to go ahead and just start on this one and replace things with sines and cosines, you really wouldn't get very far if I hadn't shown you, or if I don't show you an example as to what to do. So on this particular problem here, if I had a sine squared right there, then you could look on your green sheet and you could replace this with cosine squared down here. But the problem is I don't have a sine squared down there in the denominator yet. But if I were to take this and multiply by 1 plus sine, then I could get 1 minus sine squared in the denominator. And I can do that as long as whatever I multiply by in the denominator, I multiply the numerator by the same thing. So I'm going to do 1 plus sine times 1 minus sine in the denominator so that I can get my 1 minus sine squared. Because see, now I can look on my green sheet and I can replace that with cosine squared. But I need to make sure that I multiply the numerator by whatever I multiply the denominator by. So I'm going to multiply cosine times both of these. Cosine times 1 is going to be cosine. You're going to have to distribute. And then cosine times sine will be cosine sine. Just cosine times sine. Okay, so let's see if this can get us anywhere, make any progress. So 1 minus sine squared in my denominator now is cosine squared. Okay, so that might be helpful. And in my numerator I have cosine plus cosine times sine. Now, since I have the same denominator, or since I have one term in the denominator, what I'm going to do is I'm going to split this up into two fractions and look at them separately and see if that's helpful. I'm going to put cosine erase. Okay. I'm going to put cosine over cosine squared. So I'm going to look at this part of the fraction separately, and then I'm going to look at this part of the fraction separately, just so I can kind of separate them and see what I can do with each part. And then I'm going to put cosine times sine over cosine squared. Let's look at each one separately. Okay, so right here, what I can do is I can eliminate this cosine with one of these. So I have 1 over cosine, and remember, always look at where you're trying to get and see if you're making any progress. What is 1 over cosine? It's secant. Okay, getting there. So I'm going to go ahead and put that is secant of y, so I've made a little progress. Okay, so right here I'm going to mark out this cosine with one of those. So now I'm left with sine over cosine. Again, look at where you're trying to get to tangent. What's sine over cosine? It is tangent of y. So all of this work was done to the right hand side of the problem. So I didn't do anything to the left. Secant of y plus tangent of y equals, and then I worked on the right hand side. Secant of y plus tangent of y. So there is number 6. And I don't know if maybe you want to put a little star beside that one, just because that one was a little bit different than anything we've done so far, just so maybe it'll stand out. Okay, ready for the last one here. This one, both sides look pretty complicated, so we are actually going to have to work on both sides. We are going to work on the left, and we are going to work on the right and see if somehow we can make the left side equal the right side. So working on the left hand side, we have cotangent squared over 1 plus cosecant. Well, look on your green sheet and see if cotangent squared is, if we can replace that with something that uses cosecant, so we can try to simplify this any. Cotangent squared is cosecant squared minus 1. So that is cosecant squared minus 1 over 1 plus cosecant. Okay, now this is what we call the difference of two squares. So I can factor that into cosecant plus 1 and cosecant minus 1, and that is over 1 plus cosecant. And hopefully you see that, oh, that one will mark out with that one, and what are you left with? Cosecant of, I'm going to toss in my theta symbol, minus 1. And that's as far as that one appears to go. Now let's see what we can do with the right hand side, see if we can make any progress with it. So I have 1 minus sine over sine. Now think about what we just did on this last example where I split this problem up, where I split it up into two separate fractions. Since we have one single denominator, I'm going to split it apart, and I'm going to look at 1 over sine minus sine over sine. I'm going to look at them separately and see if that helps any at all. So I'm going to put 1 over sine minus sine over sine and see what happens. Well, 1 over sine is cosecant. I'm going to toss in my theta symbol. And sine divided by itself is 1. Hey, check it out. The left-hand side equals the right-hand side. So there you go. The left-hand side equals the right-hand side. Okay, well that's it for 5.2. Just make sure you practice on these. These are some kind of problems where you're not going to get better by watching somebody else. You're just going to have to practice them and practice, practice, practice.